Hi, today we will discuss the topic why a software needs to be engineered and how. We will discuss this topic in three parts. What is a software, why it is to be engineered and how it is going to be engineered. So the first part is what is a software. Here we will see what is a software and different types of softwares and examples of softwares. Software is a set of instructions that tells a computer how to work. The software is mainly classified into two: system software and application software. System software is a set of instructions that control and manage the computer hardware. At the same time, it also provides a platform for the smooth running of application softwares. Some of the categories of system softwares are operating system, device drivers, and translators. Operating system. You all know about the operating system. It acts as an interface between the user and the computer. Some of the examples of operating system are Android, iOS, Microsoft Windows, etc. Device driver is a software that lets the operating system to communicate with the computer hardware. Some of the devices need a device driver to communicate with OS, but some of the devices doesn't need any device driver softwares. Printer, scanner, USB, these are the devices which need a device driver to communicate with the operating system. But keyboard, monitor, mouse, and these devices do not need a driver software for communication with the OS. And the last one is translator, which convert a high-level language to a machine language like compiler, assembler, linker, etc. So now we are moving on to the next type of software, application software. Application software is a software designed for the end user. That's why this software is also known as end user programs. Some of the examples of application softwares are presentation softwares like MS PowerPoint, spreadsheet softwares like MS Excel, database softwares like MySQL, Oracle, etc. So we have covered the first part of the session, what is a software. Now we are moving on to the next part, why it is to be engineered. So in this part, we will discuss what is engineering, what is the need of engineering, evolution of software engineering, and what is software engineering. Engineering is developing products using well-defined principles and methods. What is the need of engineering? Let's take an example. We can build a house by ourselves, but the quality may be very poor. We may overlook something or we may skip some process and it may slow down the work. But if we got a qualified person to build it, the house will be ready faster than we could build it. It will be of higher quality and no steps would be skipped, and you will be confident that the house will last a long time. In the same way, we could build a software by ourselves, but it may be of poor quality and it take a long time to complete the software. If we give that chance to a software expert, he can build a software with higher quality within a shortest period of time. Now we are moving on to the evolution of software engineering. Software engineering principles are evolved over last 60 years. In the early days, the programmers used an ad hoc programming style, which is an informal style. There is no rules and recommendations that a programmer should follow. So, the software quality may be poor and it may be an unmaintainable code. So, the researchers decided to find a process that developed a high quality software. That's why software engineering evolves. Software engineering is an engineering branch associated with the development of software product using well-defined scientific principles, methods, and procedures. So we have completed the second part, why a software need to be engineered. So we will move on to the last part, how a software is going to be engineered. Here we will see software development life cycle, different phases of software development life cycle, and different software development life cycle models. So what is a software development life cycle? Software development life cycle is a process that produces software with highest quality and lowest cost in the shortest time possible. Software development life cycle, in short, it is named as SDLC. SDLC have 6 phases. They are the requirement gathering and analysis, design, implementation or coding, testing, deployment and maintenance. So we will discuss each phase in detail. The first phase is requirement gathering and analysis. It consists of 2 activities named requirement gathering and requirement analysis. In requirement gathering phase, all the relevant information is collected from the customer to develop a product as per their expectations. Requirements are gathered through interviews, discussions, meetings, or through questionnaires. These gathered requirements may contain some ambiguities or inconsistencies. These ambiguities must resolve during the requirement analysis phase. Once the requirement is clearly understood, the software requirement specification document is prepared. This SRS document acts as an agreement between the customer and the developer. After completing the requirement gathering and analysis phase, we will move on to the next phase, design. In design phase, the SRS document is transformed into design document. This is helpful for the programmers to get an idea about the project. Design phase is classified into 2, high level design and low level design. High level design, a system is classified into 3 layers named user interface layer, business layer and database layer. User interface layer is only concerned with the user interaction part. It doesn't know the background details and it completely ignores the internal working of the system. The database layer is the storage part. It deals with tables, it identifies the key elements like primary keys, foreign keys, etc. And the business layer is the logic of the system. It acts as an intermediate between the user interface layer and the database layer. For example, if we log into an application, we need a user ID and a password. The ID and password is verified with the database and display a message according to that. Here the user only enter these details and they do not bother about the verification part. It is the business layer that performs the logic behind the verification. The next classification of design is low level design. It is also termed as detailed design. It includes the detailed design of each module like data structures, algorithms, decomposition of modules, interaction between modules, etc. Latest design softwares like rational functional architecture also made the basic class and object. So it is helpful for the programmers because they have to write the logic only. The programmers' work become easier. After completing the design phase, we will move on to the next phase, implementation or coding. Here, the software design is transformed into a source code. As I said earlier, programmers write the logic that match with the design document. After coding, code reviews are take place by the experts. They check if the coding follows the coding standards like naming conventions, complex code like multiple if or while statement use, variable name labeling, etc. Programmers built the code according to the design document. After the coding phase, the next phase starts, that is testing. The testing starts once the coding is complete and the module are released for testing. In this phase, the developed software is tested thoroughly, and if any defects found are assigned to developers to get them fixed. The next phase name is deployment, that is delivery of actual software to the customer environment. Once the product is tested and if it is a success, then it is deployed to the customer environment. This adaptation is done gradually, and if any issues comes up, they will roll back into the previous version, and the programmers found the error and then get it fixed. It is again deployed in the customer environment. If the customer finds the application as expected, they accept the product. The last phase name is maintenance. After deployment, if the customer find any issues or if they need any assistance, a production support team will assist the customer. They can fix the basic problems arise during their usage. These are the phase of software development life cycle. Now we will discuss different SDLC models. There are various software development life cycle models are available, like classical waterfall model, iterative waterfall model, spiral model, agile model, etc. We will discuss classical waterfall model in detail. Classical waterfall model is universally accepted model. It is the base of all other life cycle models. Classical waterfall model is also known as linear sequential model because in this model each phase starts once the previous phase completed the task. There are 6 phases in classical waterfall model. They are feasibility study, requirement analysis and specification, design, coding and unit testing, integration and system testing, maintenance. So these are the phases of classical waterfall model. First, we will discuss what is feasibility study. The main goal of this phase is to find whether the software is technically or economically feasible to develop. The expert find out whether the software can be built using this programming language or technology, and whether the budget will meet up the actual development. After completing the feasibility study, we will move on to the next phase, requirement analysis and specification. This phase understands the exact requirement of the customer and document them properly. It consists of 2 activities, requirement gathering and analysis and requirement specification. In requirement gathering and analysis, all relevant information is collected from the customer to develop a product. These gathered requirements may contain some ambiguities and it is resolved during the analysis phase. Once the requirement gathering and analysis complete, requirement specification starts. In this specification time, analyzed requirements are documented in Software Requirement Specification Document, that is SRS. As I said earlier, it acts as an agreement between the customer and the developer. After completing the requirement analysis and specification phase, we will move on to the next phase named design. In design phase, the SRS document is transformed to design document. The programmers get an idea about the project through this design document. We already said the design is classified into 2, that is high level design and low level design. High level design deals with the user interface part, the logic of the system and the database part. In the low level design, detailed explanation of each module takes place. After design phase, we will move on to the next phase, coding and unit testing. In coding phase, the design document is translated or transformed into source code. The programmer develops the product in different modules, and the aim of unit testing is to check whether each module is working properly or not. After unit testing, we move on to the next phase called integration and system testing. During integration, The previously unit tested modules are integrated and the resultant system is tested. After all the modules have been successfully integrated and tested, the full working system is obtained and the system testing is carried out on this. System testing consists of three different kinds of testing activities like alpha testing, beta testing and acceptance testing. The alpha testing is carried out by the system developers and beta testing is carried out by friendly set of customers and the acceptance testing carried out by the actual customer itself. The acceptance testing is carried out by the actual customers. They determine whether the system meet the specified requirements. After system testing, the final working system is delivered to the customer environment, that is the deployment phase. The adaptation is done gradually and if any issues comes up, developers roll back into the previous version and find out the error and get them fixed. Then they can again deploy the final software to the customer environment. The last phase is maintenance. After the deployment of a product, if any issues arises, it will be fixed by a group of people named production support team will assist the customer to resolve the error. They can fix the basic problem during the usage. These are the phases of classical waterfall model. For your better understanding, we can compare this SDLC phases with our daily life activities. Let's take an example of constructing a house. First, we check if we have a land to build a house, enough money, getting all government approvals. We can say that we are technically and economically feasible to build a house. Then we approach the engineer for further proceedings, that is requirement gathering and analysis. We give our ideas and suggestions about our house and the engineer will analyze all the information which he gathered and he will start to prepare a plan, that is the design phase. Once the plan is accepted, we will move on to the implementation phase. Here the employees starts the construction as per the design. During respective time intervals, the engineer check whether the construction is going as per the design. This is testing phase. Once the construction is complete, the house will be handed over to the owner. This is the deployment phase. If the owner needs any modification or repair, he can approach the engineer. This is maintenance phase. Hope all of you can relate the above example with the SDLC phases. We will conclude this session by briefing all the points we discussed. Today our topic was why a software needs to be engineered. First we discuss what is a software. Then we discuss why a software needs to be engineered, and finally we discussed how a software is going to be engineered. I hope all of you have understood what we discussed. Thank you.